All right, welcome everybody to week 4, day 1. Today we're going to be talking about how to cast a variable from one type to another. And then we're also going to be talking about how to do doubly nested for loops more. Okay, so let's start off with a little bit of, and of course Putty is covering up my face again. I'll just quit out and relaunch it. That seems to fix it sometimes. Sometimes Putty just does not respect videos being on top of other videos. So, there we go. There we go. All right, wow. It's actually pretty big. How about that? Okay. So, let's start off by talking about what a character is, okay? So, you might have heard character counts. That has nothing to do with what we're talking about today. So, if you got a char, if you have like a char named Bob, you can set Bob equal to A, and you can like see out Bob, and it's going to print A to the screen, right? Now, what most beginning students don't know is that a char is actually an 8-bit integer. And so there's actually no problem. This is no problem. And you might be like, wait, what? Like, I couldn't put a squirrel in an integer. Why the hell can I put a letter? And the reason for that is because when you have a single quote, yeah, I guess that'll be a knowledge point today. Knowledge point, or learning point. Number 1, letters are actually just numbers. So the ASCII table converts a letter into a number. So if you were to say that char Bob equals A, and you print it to the screen, let's just quit here, so we won't see the rest, you'll see it prints out A to the screen. Now if I were to make Bob an int, this value is actually still the same. But now instead of printing the letter A, it's going to print the number A, the number associated with A, which is 65. And if you're wondering where the hell 65 came from, it's from something called ASCII. ASCII is the American Standard Code for Information Interchange, and it is a standard way of encoding letters into numbers, because everything inside of your computer is a 0 or 1. And so A is 65, B is 66, C is 67. And so you might be asking, well, where's lowercase a? It's down to like 96, 97, something like that. So there's lowercase a is 97, lowercase b is 98, and they're all contiguous. So you can see it goes from like 65 to 90 for uppercase, and the lowercase goes from 97 to 122. So if they're just numbers, yeah, I think you can see why this would work, right? And whether, it's just the number 65. So literally I could do this, char Bob equals A, and rather than that, I can actually just say 65, and it'll print A to the screen. It doesn't print 65. You're like, what? It's because whenever you output a char, it will do an ASCII table lookup for you. It's kind of annoying in some situations. A lot of times, you actually don't want it to do an ASCII table lookup. Like if you're just working with 8-bit integers, like for colors, if you've ever looked at a color picker, they're typically encoded. There's a couple different ways you can encode them. Let's get a color picker. So you see it goes from like 000 is black, and 255, 255, 255 is white. These are unsigned chars, so they're typically held in chars. So if you have 128 and 60 and 40, those are 3 chars holding the color value. And if you try echoing the color 124, if you're storing in a char, like let's say this is your red value, right? And you're like, I'm just going to print out, my current red value. It prints out vertical slash. And you're like, what? I wanted it to print 124, and so that brings us to learning point number 2, which is that, so this line here and this line here are identical. Yeah. Red 1, red 2. So which one do you prefer? Do you like option 1 better, or do you like option 2 better? Vote now. Operators are standing by. What do you think? I mean, I don't know. You tell me. You like option 1 better because it's option 1? All right. All right. Well, for me, it depends on whether I'm doing image processing or if I'm working with characters, right? If I'm working with characters, I'm typically going to do single quote vertical slash. And if I'm working with numbers, I'm going to do this. But if I'm working with numbers like color pickers and things like that, I actually don't want it coming out as a character. So what I'm going to usually do is actually cast it to an integer like this. So red 1 casts, converts from, get my face out of the way, converts from char to integer. Okay. So what this does here is that this converts a char into an integer, and so when you print it, it's not going to print out vertical slash. It's going to print out 124. Okay. So even though they both hold the same data, even though both red 1 and red 2 are holding the exact same thing, single quote literally does an ASCII table lookup. To the compilers, from the compiler's perspective, you typing single quote vertical slash single quote is exactly the same thing as if you typed 124. If I were to type in 65 here and type in capital A here, these two things are exactly the same from the compiler's perspective. It's just syntactic sugar. It makes your code look nicer. So if you're trying to work with letters, then you do the single quote usually. And if you're trying to work with numbers, you do the numbers. But sometimes you might go back and forth. For example, if you want job security, if you don't want people to be able to fire you, then use the wrong one. What's the color of your paint sample? Well, it's vertical slash beep $sign. Right. Mr. Bell is using hex there. Yeah. So it just really depends what you're doing. Okay. So this brings us to learning point number 2. Okay. So learning point number 2, you can cast to convert variable types. So for example, this does an implicit cast. Nothing necessary. So if we were to just see out C, that'll print out what? Is this going to print out B, or is it going to print out 66? Or sorry, let's make it a capital B. Is this going to print out? B, or is it going to print out 66? What do you think? Remember, cout cares about the type of the thing being outputted. So if the type of the thing being outputted is a char, it does an ASCII table lookup whether you want it to or not. And if you don't want it to, you have to do that, right? So is this going to print out B, or is it going to print out 66? It's going to print out 66. Very good. So you might look and be like, oh, well, that should print out B because it's B. Remember, a single quote with a letter or a symbol inside of it, it just looks up the corresponding number on the ASCII table. And again, you can find the ASCII table by typing man ASCII. Man is short for a manual. And he was a friend of mine. And you can see on here in the decimal column the code for all of the symbols and basically the basic American keyboard. All right, so you got lowercase o, open curly brace, number 8. The number 8 is 56, of course. It's not 8. That'd be too easy. So this is an old standard, and it has been incorporated into UTF-8. And so most of the internet runs on Unicode. UTF-8 is the most common Unicode standard. And UTF-8 uses ASCII. So even in UTF-8, if you were to print out what is the value of capital A, it would be 65. Okay, so this will automatically convert from a char into an int for you. No problem. Remember, chars are just numbers. Characters. I hear somebody unmuted. Chars. That's Bell. All right. Bell, you are now muted. Okay. Chars are actually just numbers. Okay. They're actually just 8-bit numbers. So they range from -128 to positive 127. Okay. And so no problem, you can do what's called a widening conversion here, which converts from an 8-bit to 32-bit. Okay, now, does that mean you can do math with letters? Yes, you can. So, let's make this a C, just so that it matches our variable. Okay, so this is going to print 67 now, right? Okay, so if I convert this, so if I add 1 to C and convert the result to a char, what's it going to print? So C is 67. If you add 1 to 67, you get 68. And then we convert that into a character, so it does the ASCII table lookup. What is this going to print to the screen? Yes, very good. It's going to print D to the screen. Very good. So this converts from int to char. And so this is one way that you can convert from int to char. This is the preferred method by C++ nerds. This does exactly the same thing, but with more typing. So there you go. And the reason why they prefer it is so that you can control F and search for it easier, I guess. I don't know. If I'm doing something simple like this, I'm probably just going to do it this way. And then this is the old school C casting method. And so in C, you put parentheses, char, close parentheses, and all three of these things are exactly the same code. All three of them are exactly the same. They do the same thing. They have the same running time, unless something's horribly gone wrong. Everything's identical. It's just a matter of preference as to which one you want to type. If I'm being professional and like having code that will be looked at by judgmental people, I do option 2. If I'm just coding for myself, I do option 1. I have literally never been burned by this choice in my life, and it's less typing, and I feel it's a little easier to read. Static cast allows you to control F and search for all static casts in your code so that you can find every place where you're casting to a char. Whereas if you just like, if you just search for char, it's going to turn up like 1, 2, 3, 4, 5, 6, 7, 8 hits, right? Okay, so let me delete this before you guys notice that. Now we're going to do a little bit of lab time. Lab time, write a for loop. Yeah. Here, before we get to lab time. This is going to print D, right? What is this going to print to the screen here? We're taking the letter C and we're adding 2 to it. What is this print to the screen here? What is C, single quote, C plus 2? And we're converting it to a char, so it doesn't print 69. It prints E. Very good. Okay, and then this one is going to print what? What letter is that going to print to the screen? The grade you're... No. Okay. There you go. All right. So, and then, okay, so this is actually unrelated. Integer, let's say string s is equal to toString c. So strings are a little bit different. Exception, strings don't work with static casts. So you use toString instead. But yeah, you could use this to convert from any of the basic types, any of the other basic types other than strings, really. Floats, doubles, ints, chars, whatever. So for example, if you want to do floating point averaging, you can do this, right? If you have like integer x is equal to 10, integer y is equal to 11. If you were to see out x plus y divided by 2, what does this print? What does that print? What is the average of 10 and 11? Remember the rule for integer division. If you have an integer on the left-hand side, you have an integer on the right-hand side, you don't get no decimals. You get an integer. So yeah, you all got it. It's 10. Now, if we wanted to convert this to a double, you do so like that, and then this will print 10 and a half. Okay. So this prints 10 and a half if you have a double there. If you don't have a double, then it prints 10. Okay. So if you want to do floating point division, cast to your double. Okay. Okay, so your lab time is to write a for loop to print all of the letters in English, both upper and lower case. And just to be fun, try to do so with as few characters of code as possible. So get it working first. I'm going to give you guys 10 minutes, 15 minutes to do this. We'll say 15 minutes. We'll do a little bit of code golf in here. So once you get it working, once you print out A through Z capitals, A through Z lowercase, it doesn't matter what order they come out in. I don't really care. You can do it either way. But you have to use a for loop. Like it's in the directions rather. All right, you have to use a for loop. You can't just like see out A, B, C, D, E, F, G. You know what I mean? Like, yeah. I don't even know if that'd be optimal. But after you get it working, and some of you, it might take all 15 minutes to get it working. That's fine. But for you more advanced students, see if you can see how few characters it will take you to print all of the English characters to the screen. The hint as to how to do a for loop to print all the characters to the screen can be found up here, right? Suppose that was A. A plus 1 is B. A plus 2 is C. A plus 3 is D, right? There should be a for loop in there. You should be able to figure out. And so, begin. I'm going to go ahead and pause the recording now. I will come back at 3:05. If you have any questions or want help, ask. Okay. All right. So I'm going to give them a little more lab time, but basically what you're looking at here is pretty close to what we're looking for. Starting at A, going to Z, and you can add one at a time to it. That's fine. The trouble with too lower is that it's one of those weird, buggy legacy things that actually returns an integer, not a character. So you need to put char parentheses too lower parentheses C, and then that'll convert it to a character when you print it. That's pretty good. That's a lot more compact than some of the other loops that we saw as an answer. I do find this one to be kind of clever. So it goes through the loop twice, first doing like lowercase, and then it sets C to be A, then it goes through it again doing uppercase. Quite clever. I like that. This one's pretty similar as well. First time through the loop, C is 65. You could have used single quote A, I guess, but that's one more character. So we are doing code golf. That will save you a character. Although all these extraneous curly braces could all be deleted if we're caring about code golfing. Yeah, here, rather than doing C++ and I++, you probably just want to do C plus I. So C plus I will do what you're looking for. You don't need to do C++ at all here. And it's going to print all the letters together with no spaces, which I guess is okay. Let's see what else we got here. So we got up and low. So, yeah. close. Probably the better way of doing this is just up plus I and low plus I is actually what you're probably looking for there. And rather than doing just make them chars, and then you don't have to do the extra char here. So you're just going to be counting up plus I and low plus I. Okay. Yeah, this has an extra cast that you don't need because A is already a character, so you're converting from character to character. Don't need it. You can just see out A, right? And this would work just fine, and that would work just fine. I would personally use single quote A, close single quote Z, close single quote, instead of making people guess. This, however, is great if you're looking for job security. But remember, if you want to get hired, you have to use proper coding techniques. And if you want to not be fired, that's when you bust out the bad things like this. So, so for int I equal, and you do like this, character C is equal to single quote A, C is less than or equal to Z, C plus plus, C out C, followed by space, followed by char to lower C. Something like that. And then you got A through Z and A through Z. Yeah. So I feel like that's reasonably code golfy. I can probably do a better job by probably cut down on this a little bit. What's the difference between A and I know. Let's see. And ASCII 65, and that's 97, so it's 32 off. So reading integers. There we go. So lowercase letters are exactly 32 above their uppercase version. And so just by adding 32 to it, that might save you a couple characters. If I wanted to, I can cut out some spaces. There. That could be 65. You're going to fully code golf this. That is what, 90? Is it? No spaces anywhere. You can see it there. There you go. So I don't know how many characters that is, but what is that? 55 characters? It's okay, I guess. All right, I'll post that on the Discord. You can admire it at your leisure. So, 55 characters. Can you beat the professor? You tell me. Probably do this faster with a printf statement. Let's see. A through Z, A through Z. Yeah. All right, so that's only, what is that? 49 characters. Okay. That's a little bit smaller. Oh yeah, good call. Yeah, we can shave one more letter off. Very good. By making that less than 91. Yes, very good. Very good. So that takes us down to 48 characters. Oh. Seems about right. I mean, we could probably get rid of the new line or something, but whatever. Okay, so that is that. Hope you had fun with that. Now we're going to talk about doubly nested for loops for the remainder of class. So a doubly nested for loop, and I will purge this and start over. CC, what? Yeah, okay. So doubly nested for loop is very commonly used for n I equals 0, I is less than 10, I plus plus. Remember, always do your curly braces first. In lab time today, I saw a lot of students forgetting to do the curly braces first. And then when the curly braces don't match up later, it's like, I don't know what to do. Okay, so, let's see how, I don't know. I and J. Here, okay. So this is going to print out 100, it's going to run 100 times, right? Because the outer loop runs 10 times. Then for each time the outer loop runs, the inner loop runs 10 times. How many times is the inner loop, is that line going to run now? What do you think? Do the math. How many times is it going to print out the values of I and j, let's say? Okay. And how many times is it going to print end line? How many times is it going to do this? 10. Okay. How about now? How many times is it going to do that line? Space on there. 10. Okay. And then how many times is it going to print new line? 2. There. Okay. All right. Sounds pretty good to me. There we go. Okay. So let's talk about the use of 2D arrays or 2D loops like this. So why a doubly nested loop? Actually, sorry, I just told you the answer. We do it a lot when working with 2D data. So for example, for your lab time, you're going to be counting how many checkers there are on a checkerboard. So I've given you a function that tells you at a given row, at a given column, is the spot there covered, is it blank, or is it covered with a white piece, or is it covered with a black piece? And so you're going to usually do something like this. So if you have like a 10 by 10 board, then you typically do this, and you might be wondering, like, what is that const thing there? Well, the const thing there means the variable is read only. The only time the variable can be set is when the variable is made. So if I ever tried changing the value of rows down here, if I said rows is equal to -1, this will not compile. It is a read-only variable. Okay. So we typically write const variables, which are called constants, in all caps. It's a traditional coding style. And so if you're ever going to work over like a tic-tac-toe or Battleship or any Go, Pente, chess, checkers, any 2D sort of board, you're probably going to have somewhere within it a 2D array like this. And you can think of this as like, oh, I have that backwards. You typically do it like this, actually. Like this, not the other way. You typically go one row at a time, like you're reading a book, right? So you're going to start off on row 0, right? When I is 0, that means like row 0, and you're going to start off at column 0. And then you're going to go to column 1. So you start off at row 0, column 0, row 0, column 1, row 0, column 2, row 0, column 3, row 0, column 4, just like you're reading a book. And you might do something like, you know, if the value here is a white piece, add 1 to a variable that counts how many white pieces we've seen. If the black piece, add 1 to the variable counting how many black pieces we've seen. And then after your for loop is over, you could say something like, if there's white pieces on the board and no black pieces, white wins. If there's black pieces on the board and no white pieces, black wins, right? For checkers or something like that. Okay. So this pattern, comes up all the time. Battleship, for every row, for every column in that row, see if there's a ship that has not been hit yet. And if you don't find any, you lose, right? It's like basically in Battleship, if every spot on the board is either ocean or a hit ship, you've lost the game. And so it's going to be the same kind of like for loop like this. For every row, for every column in that row, and that's going to sweep through the entire 2D world, just like you're reading a book. It's going to visit every square on the board. And this is the pattern you're going to follow. Okay. So I've deployed to your directories. So cd into doubly nested practice. So inside of here, you will find some sample code. And this is what you're going to be working on for lab time for the remaining 20 minutes of class. And so what I want you to start with is printing the board to the screen. So use that for loop I just showed you and just print the value at every spot on the screen. How do you get the value of a spot on the screen? Well, I've given you a function. You don't need to know anything more about it. Just that you can call this function get piece at location. You pass in a row, you pass in a column, and it will report to you it's white, it's black, or it's blank. Okay? And one of the neat things about using constants like this is that you can actually use the variable name, white or black or blank, which makes it a little more human readable, right? So like here, you can say, give me what piece is at location row 4, column 7. And you can say if that piece is white, then we're going to print out, things white. If the piece is black, we print out it's black. Otherwise, we print out it's blank. So what you're going to essentially do is take this kind of thing here and put it into a doubly nested for loop. So you're going to put it into a doubly nested for loop where instead of having a fixed row and a fixed column, they're going to be I and J. Okay? Using the pattern that I showed you earlier. And you're going to start off, step 1 of lab time is just printing the board to the screen. So you're going to print out the board. I've got 3 pre-generated boards for you. You're going to pick either 1 or 2 or 3. I'm not sure what happens if you don't pick one. I think if you don't pick one, it defaults to 3. So the first thing you're going to do is print out the board. And then if you get that done, then count how many white pieces are on the board and print that out. Count how many black pieces are on the board, print that out. Count how many blank spots that are on the board, print that out. Now you might think that blank spaces aren't useful, but in a game like tic-tac-toe, if there's no blank spaces, it's a draw, right? If nobody's won, right? And so keeping track of how many blank spaces is probably useful, or you could probably do some algebra. You could add the number of X's and the number of O's, and if that reaches 9 without there being a winner, then, it's a draw, right? So there's always different ways of doing these things. So, and then if you get that done in 20 minutes, which would be impressive, then check to see if one side has pieces and the other doesn't. So if the count of white pieces is positive and the count of black pieces is 0, then print white wins. If the count of black pieces is positive and the count of white pieces is 0, print black wins. Okay. So that's basically what you got to do for the remainder of class. I will return in 15 minutes. So let's see how much you guys can get done. And if you don't finish it all right now, then we will pick it up again on Wednesday, I think. Because I think this is a pretty good exercise. There is a homework assignment that's upcoming that is related to this. I actually have several. I've got Battleship, I've got Connect 4, I've got Pente, I've got Tic-Tac-Toe. There's a lot of games that use this pattern. And so I'm going to just put the pattern up on the board here. Use that for loop and use the function get piece at location, whatever it's called. rather than hard coding in 4 and 9, put in I and J for them. Okay. What assignments am I thinking? Depends how well the students do. So make sure you do badly in lab time so I have low expectations. Okay. All right. Okay, so begin, and we will return at 3:39. Okay. I'll just leave this up, I guess, for lab time. Okay, so let's take a look at this. Wow. Aaron's plugins are not working. There we go. Okay, so here's what you got. You got some demo code here that you're supposed to delete. I would personally just, kind of like comment it out a little bit like this. And then your goal was to like maybe write a little for loop like this. And do a little bit of that. And probably just do this. Yeah. Application. And blind, a little bit of this, a little bit of that. I and J. And that was your job. Not with an inline, maybe with just that. Here. Okay. And so there's board 1, board 2, and board 3. Now, in case you're worried about that looking too easy, remember that I've been coding for a while. And the thing that we're trying to get you in the mindset for is understanding a 2D loop. Okay, so you have a function that will give you a piece at a location, and you need to use that in a 2-dimensional loop, in a doubly nested loop, to say at every row I, at every column J, tell me the piece there, and that's what this is doing. The first time through the loop, I is 0, J is 0. This is going to print out the piece at board position 0, 0. Next time through the loop, it's going to be row 0, column 1. It's going to print out the value at row 0, column 1. It's like reading a book. And so this is just going to print all the piece information. And then after it gets to the end of a row, hits the enter key and moves to the next row, and then prints out all the thing in that row and prints out all the thing in that row. This is a pattern that you need to learn. Okay. So whenever you do anything with 2D data, like a board game, like we're talking about is a 2D, data structure kind of thing, you're going to use a doubly nested for loop. Anytime you work with 3D data, like if you're going to be averaging temperature data in a 3D space, it's going to be triply nested. Your for loop is going to look something like this with another one of those and another one of these, and it's going to look a little bit like this. Rows, columns, and planes, something like that. And so if you had a 3D board, it would look kind of like that. Okay? If like if you wanted to get the temperature at every spot in 3D space, this is how you do it. And let's say that this function here returned the temperature at a point in space. All right. So, and you wanted to print out all the temperature of the bucket of seawater you're simulating or something like that. This is how you do it. For every row, for every column, for every plane, print out the temperature at that location. This is the pattern you have to kind of get used to. Now, since a lot of you didn't get any of this done, what I'm going to do is I'm going to, for one thing, this is going to be very similar to an upcoming homework assignment. So I'm going to give you more lab time on Wednesday to work on this. If you want to think about it in the meantime, think about, okay, now that you know kind of how to get the piece, you can think of I as like the row, right? You can think of this as like the row. And you can think of J as like the column. That helps. Something like that. So for every row, for every column, print out the piece allocation. Now that you know how to access all of the data on the board, think about how you'd go about counting how many white pieces there are, how many black pieces there are, and seeing who would win. Okay, so you're probably going to need to make some sort of variable up here, count each of the pieces. You'll probably need some if statements down here to see which one's winning and which one is won. Okay, so think about that before Wednesday, and I will continue this lab exercise on Wednesday because I think it's pretty valuable. A lot of students have trouble wrapping their minds around doubly nested for loops, kind of like conceptually, and like writing the code, it like hurts the brain, and that's normal. And so the only way to get good at something is just to do it. And this is a low cost, low stakes thing, because like this didn't cost you your grade or anything like that. It's just you get to know if you know what you know, and if you don't know it, then you get to see the answer and try again on Wednesday. So the Zybooks is due on Wednesday. Make sure you do that. I'm not going to downplay it. It's a lot of work, but that's the amount of grinding you have to do in this class to get good. Like you can't get good without putting in the time, putting in the effort to do it. I've run the stats on this before. The only students who do well in the class that don't do the Zybooks are the students that already know how to program. That's really what the data shows. So if you've already learned how to program, like, half-ass it, whatever, I don't care. But if you are like most people in this class and have never programmed before, you have to go through the Zybooks. If you don't, it's just going to be a train wreck. You're going to be lost and confused. And like, how do I make a variable? I had a student at the end of last semester, like, not know how to make a variable. And I was like, how did you get to the end of the semester? It's just like, this, you can't write any code without variables, like almost at all. So how did you make it this far? You know what I mean? It's like, you gotta, the first 4 Zybooks especially are really crucial. Like maybe the first 5 weeks. Like you just absolutely, if you've never coded before, you absolutely have to do everything in them. Maybe if you are running out of time, like skip some of the programming assignments. They're only like 10 points each, so it's not like a huge hit to your grade if you're going to skip some of the programming assignments. But like, try and do everything. It's really, really crucial to understanding. And inevitably, the students that are struggling, I look at their Zybooks, and it's like, oh, they didn't do them. It's like, well, like my Japanese instructor used to tell me, she's like, I can't memorize vocab for you. You have to memorize the vocab. Like I can teach you the grammar, we can do exercises in class, but I can't force the vocab into your brain. You have to do that. You have to put in the work, And so at a certain point, it's like she just tosses it to you. It's like, here's your responsibility. Here's 40 words. You have to have them memorized by next week. That's, you need to do that. I'm not joking. You actually have to sit down with flashcards and memorize these things by next week. And it's like that with the Zybooks. Like you have to do them. Like it will not get better if you like skip over the Zybooks, especially the early ones. They're so crucial. They're so foundational to all of programming that like, it's just, you're going to need to knuckle down and do them. Okay. Zybooks are OP. Part of the reason I do them along with you guys to master what I know. Yeah, that's your TA. Like he runs through them also just to work on his skills and to work on, getting himself better, working on the basics and things like that. So, even like when I became an experienced programmer, I was constantly returning to the basics and making sure that I knew how to do things like there are these things called like code katas and things like that where you can like practice different basic coding skills and things like that. And I do those constantly, seeking to better my craft and constantly get better. It's like, does anyone here play music? Is anyone here a musician or has aspirations to be a musician? Play guitar? Okay. So how important are like scales to music? You know what I mean? Vocalist? Like how important are scales? Like they're not fun exactly. Like I always kind of found them a little fun on the violin. There's like a little finger pattern you learn to play them. But like imagine like trying to learn to become a musician without like playing scales. Like you could do it, maybe. Like if you don't practice the chords on a guitar, could you learn to play the guitar? Maybe. It's kind of like, yeah, it's just so foundational. It's like you know, I guess, I really don't recommend it though. Like you need to sit down, you need to practice your scales, you do your arpeggios, you do your chords. Um, it's just the kind of thing that in music, like when I'm warming up, I will play a scale, like just to make sure, that my fingers are in the right place because the violins don't have frets, you know what I mean? Like, so you need to make sure that your fingers are in the right place. And also as the strings loosen up and the temperature changes, like the point where you're sounding a C or whatever moves slightly. Um, it's comforting and reassuring to get through skills. Yeah, it's like that for programming. Okay. So you have to think about programming in the same way. Like if you want to be serious about music, you have to work on the basics. And Zybooks is the basics. And that's why Mancrelli's practicing it, even though he's an experienced programmer at this point. Everyone wants to jump at the cool sounding stuff. Yeah, exactly. Like, I want to write World of Warcraft. Now you gotta know how to make a variable. You need to know how to do input and output. You need to know how to do algebra. You need to know how to do a branch, a conditional. You need to know how to do a loop. You need to know how to do a function. And once you know that, those are the basics. Once you know all that, you do them all again. And once you know that, you do them all again. Like you just keep working on it. You keep practicing and things like that. So yeah, if you skip the Zybooks, it's like skipping skills in music. So I won't lie to you, it's a lot of work, but put it in. Okay, that's it for today. Void, we'll talk about that when we get to functions. Okay, so that's it for today. Thanks everyone for coming out. Good job working hard today, and like I said, we'll continue this on Wednesday. Peace.